Hello dear friends, I welcome you all for the lecture number 4 on Hammett linear free energy relationship. In last lecture we have discussed about the reaction constant. In this lecture also we will discuss more about our reaction constant or detail about the reaction constant. Now value of value of reaction constant. The value of reaction constant may be small or it may be moderate or it may be large. The small rho value is in when the reaction value of reaction constant is in between 0 to 3, then it is considered as small rho value. When it is in between 3 to 5, then it is considered as a moderate rho value. When the value of reaction constant is in between or more than 5 or more than 6, then it is considered as a large reaction value of reaction constant. So here basically we have three examples with different value of reaction constant. For the first reaction we have rho value is equal to plus 2.7. For second we have a rho value equal to 4.09, and for the third reaction we have rho value is 9.0. In all cases we have a positive sign of reaction constant. It means the electron density in all these three reactions are coming towards the electron reaction center. The electron density in for all these reactions, for all these three reactions, the as the value of reaction constant, the sign of value of reaction constant is positive. It indicates that the electron density is coming towards the reaction center during transition state or during intermediate formation. So in first reaction or for a first reaction we have a small rho value. Now consider the first reaction. In this anion, this Wittig, you can say that the phosphorus ylide attack over a carbonyl carbon attack over a carbonyl carbon, and formation of this anion is taking place. Alkoxide anion is taking place. This alkoxide anion is now not in conjugation uh, with this benzene ring, not in conjugation with this benzene ring. And as this negative charge or alkoxide anion is not in conjugation with this benzene ring, this reaction is having very small rho value, very small, or you may say that not very small, only small rho value. This is because this negative charge is not delocalizing over this or with this benzene ring, and therefore the effect of this substituent in stabilizing this conjugate anion is small, and therefore we have small rho value. That is, this reaction is less susceptible towards the polar effect exerted by substituent. If we consider the second reaction, in case of second reaction where this piperidine attack over a electrophilic carbon, and leads to formation of negative charge. Now this is a simple addition elimination mechanism of second reaction is addition elimination reaction, where mm, where the electron density is coming towards the reaction center. Electron density is increasing towards the reaction center during reaction, and therefore this second reaction is also having the positive rho value. Now the positive magnitude of this positive rho value is considered as a moderate rho value. This is because the corresponding carbon, this is because the negative charge, the corresponding negative charge form is now delocalized with this nitro group, as well as this benzene ring, In short, this negative charge, the corresponding form negative charge is now delocalized with nitro group as well as with pH ring, or array ring, and therefore the value of rho is increases. As here the corresponding negative charge it gets stabilized by this substituent constant. Is stabilized by this substituent constant. And if we consider the third reaction where we have a very large rho value, that is plus 9.0. This is because in this reaction this butoxide anion attack over a vinyl vinyl carbon, and the corresponding carbanion form the corresponding uh, carbanion. Now this corresponding carbanion is greatly stabilized by this AR system, by this aryl system. It means the negative charge form is now completely delocalized with the aryl system, and therefore we have a large we have a large rho value. We have a large rho value. In short, in conclusion, we can say that whenever the any reaction in any reaction where there is a formation of negative charge, where there is a formation of negative charge, and if that negative charge is delocalizes over a benzene ring or over a aryl ring, then that then such a reaction will have large positive rho value, will have large positive rho value. Now what is the reason for this? Because whenever there is a stabilization of such a negative charge, whenever there is a stabilization of such a negative charge is take place by this aryl ring, then in such a reaction the effect of X in stabilizing such a negative charge is more, and thus there is a more susceptibility of the reaction towards the polar effect exerted by substituent. When the formed negative charge is away from the benzene ring and not delocalizes directly with this benzene ring, then in that case the stabilization of this particular type of negative charge, stabilization of this negative charge will not take place by this X, and therefore the role of this substituent will be less in stabilizing that particular intermediate, and less is the role of this substituent constant, smaller will be the rho value, and therefore uh, the rho value is considered as a measure of susceptibility measure of susceptibility towards the substituent constant, measure of the susceptibility of intermediate towards the react and towards the substituent constant. Now let's consider the rho value with a positive with a negative sign, here this reaction is having very small rho value. This is because the negative charge. This is because this negative charge before reaction with this ethyl iodide, this negative charge it delocalizes, it completely delocalizes with this pH ring. But when this phenoxide anion reacts with this ethyl iodide by S into simple S into reaction. The negative charge now become partial negative charge, and therefore the delocalization of negative charge or extent of delocalization of this negative charge is now decreased, and it means that the electron density towards the reaction center is decreased, and therefore it will have the very small rho value. It will have very uh, small positive rho value. Sorry, it will have the very small negative rho value as electron density is going away from the reaction center. In second reaction, we have a moderate negative rho value. We have a moderate negative rho value. This is because in this is the simple the example of SN1 reaction. In this SN1 reaction, the third butyl or third aryl chloride is mm, uh, aryl chloride is undergo the solvolysis or hydrolysis and forming a carbocation. Now, as this carbocation delocalizes with this pi electron system, pi system of this benzene ring, so it will have the moderate negative value. Now, why the rho value is not large for this reaction? This is because the positive charge, the formed positive charge is not directly on this benzene ring. If we consider the third reaction, then this reaction is having large negative rho value, that is minus 6.4. This is because after the reaction of benzene or after the reaction of substituted benzene with this nitro group, the formation of sigma complex, where the positive charge is directly formed on the aryl carbon aryl carbon and which completely delocalizes with this pH ring, and therefore rho value is when the rho value is large negative. So in conclusion, we can say that whenever there is a formation of positive charge, directly on the ring, then it will have the large negative rho value. When the resultant carbocation formation take place, it's slightly away from this benzene ring in the reaction, then it will have moderate negative moderate negative rho value. And if any reaction is not forming a directly positive charge, and just the uh, disappearance of negative charge is taking place, in that case, the we have a very small negative rho value, because in this reaction no directly formation of positive charge is taking place. In this reaction, only the disappearance of negative charge is taking place, and disappearance of negative charge will always have small rho value. So in this way we can categorize the particular reaction constant for the particular reaction as a small, as a moderate, or as a large. Okay. In next slide, we will we will discuss the use of Hammett row value to discover the mechanism. So Hammett row value play important role in determining the reaction mechanism of the reaction. So here we have, this is first reaction. We consider this as a first reaction and consider this as a second reaction. Now here first reaction is a simple bromination reaction. First reaction is a simple bromination reaction, and we have a dibromo derivative. For this reaction, we have moderate, sorry, we have a moderate, or you can say large negative rho value. So from reaction constant, we can have a mechanism like this. Or there are two possibilities for this dibromo derivative formation. This carbocation is formed, which can be easily attacked by this adjacent bromine atom. Let me erase to form cyclic brominamide. To form this cyclic brominamide, and then mm, now there are the two possibilities. That is either the formation of carbocation or formation of cyclic brominamide. But as we have a moderate or you can say the large negative rho value, it clearly indicates that there is a formation of carbocation. There is a formation of carbocation. If no such a carbocation formation take place, then the rho value expected for this reaction is in between 2 to 3, or you can say the reaction value of reaction constant for this intermediate will be rho is equal to -1 to -3. But as we have experimentally, we have a rho value is equal to -5.7. It clearly indicates that in this reaction, no cyclic bromine formation is take place. And in this reaction is occur via formation of carbocation rather than your cyclic bromine. So in this way, we have a dibromo derivative. And from the data we have, we can conclude the, or we can determine the or discover the actual reaction mechanism for the reaction. Now why this is what is the explanation for this, that the no cyclic bromine formation is taking place, and here carbocation formation is taking place. So explanation for this is benzylic carbocation. This reaction give rise to benzylic carbocation, which is very much stable due to the delocalization of this positive charge with this benzene or aryl ring. Now, if we consider the second reaction, this is your substituent at meta or para position. Here also this pi bond attack on sulfur and um, departure of leaving group is take place minus. So here we have a positive charge formation. Now, as the rho value is very small, or not very small but small, that is rho is equal to -2.7. So uh, in this case, this rho value is clearly indicating that this reaction is not involve the formation of carbocation, and therefore, for this reaction, the correct intermediate form is sulfonium ion. Is a cyclic sulfonium ion. As we have very small rho value, not very small rho value, that is -2.7. Because If this reaction is occur via carbocation formation, then the expected rho value for this reaction is in between -5 to -6. But as we have rho value is equal to -2.7, it clearly indicates that the formation of sulfonium or this reaction is occurring via, or this reaction take place via formation of sulfonium ion rather than this carbocation intermediate. So in this way, mm, the value of reaction constant suggests about the actual reaction mechanism for the particular reaction. Thank you.